Okay, what we're looking at is a Fluke Model 1900. Um, this is a 5 hertz to 80 megahertz frequency counter by its specifications. However, we'll be able to beat those specs, and we'll prove that in a little bit. It's in very good condition. The case is shiny. Very few abrasions or scratches of any kind. The handle is in good shape. The faceplate is in good shape. As you can see the shine off the faceplate. Underside. And rear. So it's had a pretty good life. There's the only thing I can point out here is there's a little bit of an abrasion in a couple spots here, but honestly it isn't bad. It's in really quite a remarkable condition. Now, right at the moment we're putting out a 10 megahertz signal from this rubidium source. I'm verifying it using this Hewlett-Packard 5345A counter, and as we can see the counter is saying that we are 10 megahertz right down to a hertz, so that's as close as the counter was able to get it. I suspect that the rubidium is actually accurate probably to the 100th, maybe even the 1000th of a hertz. And we're inputting that signal to this Fluke 1900A, and as you can see we are reading 10 megahertz. We're reading it. We can go to the auto range. First step. Alright, then we're gonna switch everything off to the left. We're gonna pick up an additional 0 on the right when I go to the next range. We'll watch for a moment. It'll be the tens place. Alright, this is the 1 spot. So it's saying that we are roughly 5 hertz out. I'm going to a 10-second average at this point, and we'll see if it's truly 5 hertz or if it's just slightly less. Okay, it looks to me like we are truly at 5 hertz out. So we are within 5 hertz of 10 million on this counter. That's pretty doggone good. I mean, if you do the math yourself, divide 5 by 10 million and see what your error is, percentage-wise. Okay, let's go ahead and show that the counter now can read other frequencies besides 10 million. Obviously, we don't want 10 million all the time. That would be 11, 12, 13, 14, 15, 16, 17, 18, 19. Alright, let's go to 20, 30, 40, 50, 70, 80, 90. Alright, we can go to 99, display it. But how about, what if we went in fact, I go 108. 108 would be the maximum on this particular unit. It's supposed to be 80, but we can get 108 out of it. Let's go down to the other end. Alright, we are at 8 megahertz. Going to 1. There's 1 megahertz. It's 1,000 kilohertz. That's what's happened on the scale. Remember, we're in auto range. Now, should be able to pick up an additional 1,000.00 kilohertz. 0.0001. This is what I would expect. It's reading a very accurate standard, and it's giving you a very accurate output. Let's 900,000. We'll go to 9, 8, 7, 6, 5, 4. I think we can give ourselves another step or two. That's 400 kilohertz. 300. Now we're at the limit of what this PTS generator is going to put out here. So we're going to switch, and we're going to go to a different generator. All right, here we are at 300 kilohertz again. 200. 100. 90, 80, 70, 60, 50, 40, 30, 20, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, that's 1 kilohertz. There's 900. Sorry. 900. 800. 700. 600. 500. 400. 300. 200. 100. 90. 80. 70. 60. 50. 40. 30. 20. 10. 9, 8, 7, 6, 5, 4, 3. All right, now I'm going to give ourselves one more step here. We're going to pick up an extra digit, but it's going to cost us in terms of the amount of time it takes to do the average. We're going to get a 10-second average here. All right, we are at 3 hertz, going to 2, there's 2, how about 1? I have a 10-second average. It takes us time. But let's see if we can get 1. That's 1. That extra count, that's pretty standard. Your plus or minus a count always. So there we are. We've gone all the way down to 1. And all the way up to 100 and, was it 8? I believe it was 108. So 1 to 108 megahertz on this 1908. Now, along with that counter, we're going to provide a user instruction and service manual, which will take you through specifications, operating instructions, theory of operation, maintenance of it. And here's some block diagrams for troubleshooting. And at the very back, I've provided schematics, schematic information on 11 by 17 paper, which I'm having trouble handling one-handed. Sorry. But I provided on 11 by 17 so it's easy to read. It's a very good manual. And then along with that, I'm going to throw in a set of test leads. To get you started. So it's BNC to gator clip test leads, RG58, exactly what you need to get you started. So there you go. We'll give you the whole kit and caboodle if you happen to be the winning bidder. This really nice looking 1900A. It's in very good shape. Happy bidding.